Hi everyone. Today we're gonna recap some of the Python skills. You might already have learned it from previous classes in the junior, uh, sophomore, and freshman levels. But I just wanted to check if you guys know all the important stuff that you need to know for this class. So we're gonna start with the variables. There are a lot of different variables in Python, including integer, float, string, character, boolean, list, tuple, dictionary. And then I assume you guys know all these, including integers, float, string, character, boolean. But unlike C or C++, in Python, integer and float, you don't need to declare anything or even other variables. You only just use by just putting numbers, strings, characters, boolean, list, tuple, and dictionary. And the Python program automatically finds out if it's integer, float, string, or and so on. So, for example, if you want to declare an integer, you can just simply say a equal 1, something like that, is equal to 2, that's an integer. And then float is something like 1.1, b is equal to 2.3. And then, for example, this one is an integer. But how does Python know if this is an integer? And this is float. If you have this decimal point, Python program automatically finds out if it's float, and then if not, it's an integer, if it's numbers. Okay. So for example, type of A should be an integer, while type of C should be a float. Okay. Okay. And then another thing is that if you have an integer, but if you want to convert that into a float, what you can do is that float of A, and then if you print type of E, and you can see it's float. Even though you started declaring that as an integer, you can convert that as a float. Okay, and string is something like starting with the uh, parent, parented, uh, and then putting characters inside A, B, C, D, or just 1, 2, something like that. And then they are all string. And then if you see here, they are all strings. Okay. And then when you take a look at these two, even though they are numbers, they are in um, string type. And then if you want to convert that to integer or float, you can simply do int and g. And then if you print it, you can see, you can see uh, type g. Then you can see it's converted to the integer, right? And for strings, there are multiple different types of declaring a string. For example, hello world with the two parentheses, and then the hello word, single. C, you can do 3. Then you can do 3 symbols. If you print A, B, C, and D, oops, maybe. Then you can see they are all hello words, right? And then if you wanna, the reason why we have those multiple different ways is that, for example, if you wanna use single quotation mark within the multi quotation marks, then you can do something like hello world to use single quotation mark inside, so that you can have hello world and then quotation marks. And then you can flip it, meaning you have double quotation marks inside like this. And then um, you can also do line breaking, like equal to hello, then n backslash n to have a line break like this. And then the use of 3 quotation marks like this, you can simply press on enter to do line breaking. So the use of 3 single quotation marks is for this. Okay. And for the integer and float, when you have a is equal to 1, b is equal to 3, or it's 3.5, and then when you take a sum, that's gonna be 4.5. And then if you type the a plus b, what would that be? That should be integer plus float becoming float, because 4.5 is actually a float. But then if you have string, the first string hello, and then the second string word, and then if you do C plus D and print, what would that be? It's gonna be simply appending C and D, or C with D. So you have hello and word like this. So that's different from the summation of integer or integers and floats with the summation of strings. So for example, if you have 1 and then 2, and then if you take 1 plus 2 for this, uh, ideally, if you are using integer like this, the answer should be 3. But then for this, the answer should be 1 and 2, 1, 2 in string. Okay? So they are different. They are used in different ways. And then multiplication does the same. So let's say if you have D and multiply by 2, and then you're just appending the same string over and over again. So like if you have 10, then you should have 10 ones. Okay. And if you want to get the length of this string, you can simply do len and d to have the length. Now d has 8 characters. So the length of the string is 8. Okay. And then if you have a space in between, it should have another space, or take another space, so that it has 9. Okay. And then you can also do see string indexing and slicing. For example, like H is equal to hello world, for example. If you print out hello world H10, then you should start, Python always start its indexing with 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the answer should be H of 10 should be D. Okay. And then 5, 0, 1, 2, 3, 4, 5. So that's gonna be an empty space bar like this. Okay. And then you can also do -1 and -2 and so on. That's going on reverse away. So -1 is at the last character of the string H. So it's gonna be D. And then -2 should be L. This string indexing, uh, assigning value with the indexing is not possible when you do, for example, like this. You see, it's giving an error, saying that the string object does not support item assignment. Okay, so can't do this. For string slicing, you can do starting with the end and then colon to get the slicing. Then you can see 0 all the way to before 5. So it's like 0, 1, 2, 3, 4. And then you don't include the last one because 5 meaning 0, 1, 2, 3, 4. Okay. So you see there's no space, right? And then if you use like this, you can see it has space because 0, 1, 2, 3, 4, 5. Okay. And then you can simply um, get rid of 0 to get the same answer. Okay. And then if you want to start with some value and then get the indexing for the rest, you can do something like this. And then it's going to be 0, 1, 2, 3, 4. So it's going to be word without space. Oh, sorry. 0, 1, 2, 3, 4. So 4 and then word like this. Okay. And then you can also do -1 like this so that you can have hello world and then but before the last one. So like this. Okay. And then um there are string you can you can use count for example a print a count and L to count the number of L's, 1, 2, and 3. Oh, sorry. Count, count the numbers of L's. And then you can simply also do H find L to find the index of the corresponding character L. So it's going to be 0, 1, 2, 0, 1, 2. And then there also L in the third, and then the second last. But the find, what this does is to find the first character that you have here and then return it. So it's gonna be 2. Okay, and then if you wanna go from the back to the front, meaning the reverse away, you can do this rfind to go from back. Okay, so 9 over here. Okay. Then you should also know join, upper, lower, L strip, R strip, strip, but I won't go into too detail. There's replace as well, but you should know. I think you should know all that. Those stuff that I explained are the most important things in the string. And then we're going to move on. So we finished integer, float, and string. Pretty much characters as well. And then we're going to move on to Boolean. Boolean is simply true or false. Okay. So if you print the type, it is Boolean, right? And then you should be able to distinguish that with string with true. See, the first one is Boolean and the second one is string. And then you can do the same, similar, you can also have Boolean by just having the comparison statement. For example, 1 is equal to 1, that is true, right? So that's Boolean. And then you can, if you type, you can see it's Boolean. And then you can do also 2 is equal to 1, and that's true. And then if you flip it, you can see it's false. Okay. All right. That's Boolean. Before we moving on to list tuple and dictionary, I guess you should already know control statements like if and else, elif, and loops, for loop, while loops, all those. And we're gonna move on to tuple first. So tuple start with the parenthesis like this, and then if you wanna put values like within the tuple, you can do something like this. If you have just one, and if you have multiple values in a tuple, you can do something like that. And then if you wanna have string and numbers together like this. And then if you print this out, you can see you have strings and then numbers together. Okay. And then you can also do tuple inside of tuple, meaning T5 A, and then you have another tuple like this. And then if you print this out, you can see tuple inside of tuple. Okay. And then I'm gonna explain more in detail about the list, but the list, it looks like the bracket instead of the parenthesis. So like this, and then tuple, as I mentioned, it is with the parenthesis. And then the difference is that when you print this out, you can see the parentheses for the tuple and the brackets for the list. That's one difference, but not only that, if you overwrite the values, for example, L1, and you wanna replace this one with 4, for example, then you can do indexing 0, 1, 2. So L1 of 2 is 4. Then you can see it's one, it changes to 1 to 4. But then for tuple, if you do it, you get an error saying tuple object does not support item assignments. So that's the biggest difference. Tuple doesn't allow item assignments for when overriding, and list does allow. Okay, and then you can do same indexing and slicing for tuple as well, like when you did right, when you did for the string. For example, T1, 0, T1, 1 to 3, T1, all the way to 3, T1, 1 to the end, T1, 1 to 3, 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 T1, 2 minus 1. Everything is possible. And then if you do tuple summation, let's say like this, and then if you do T1 and T2, what would that be? Um, okay. All right. So when we have just one tuple, one variable in the tuple, it gives you an error because it says um, can only it can only concatenate tuple to tuple. But then if you have just one variable, it's considered as a string because that's just one variable or one value inside, and that's a string. So you cannot do this. But if you have multiple values in the string, you can do summation. And then as you saw in the string, you can also see the same thing by just concatenating um, the values for tuples. And then multiplication, you can see the same thing. So it's 1, 2, 3, 4 as list. So it's, sorry, string. So it's 1, 2, 3, 4 and 1, 2, 3, 4. Okay. And then length, you can do the same thing for the length like this. Okay. And then we are gonna cover list, but it's also pretty much the same, except that a list you can override values. Okay. So you can have brackets and then like this. If you print C, you can see a list uh, with all the components. And then you can do the same for indexing like this, like this, like this, and then like this, like this. Okay. You know what it is. We already have learned the same thing for in the string and tuple, right? And then you can also have list inside of the list. So for example, 1 and 2, and then you have another list inside, live, cool. Then if you print out D and then 0, uh, you you print this one, right? But then if you print 2, you print the whole thing of this, like this. And then if you wanna only choose live, then you should also add another bracket and then say 0 to print out live. Okay. And then if you do 1, you print out cool. Okay? And then you can do the list slicing, everything with for the second with the list instead of the list. And then you know how would summation, multiplication, and length work, which should be the same as tuple and string. And then one good thing about using string is that you can change the list values in a list. For example, if you delete um, like this, and then if you print C, you can see life is gone. So you see C of 0, which is the first index. And if you go with bell, you delete the first uh, index value. Okay. And then you can do also the same thing for by doing the indexing like this. And then you can see from the third one, it got rid of. Okay. So you only have life and leaf. Okay, and then you can do append. So for example, here, if you add another component in the list at the end, you can do something like this. And then if you print it out, you can see it's added. And then you can also add list with in the list like this, for example. Then you can see list has been added, and then you can also there's also a declaration you can use for reversing the list like this, and then you can see the components order has been flipped. The cold flow is light, and then if you let's say have 1 to 3, and then if you reverse it, you can see 3 to 1. And then if you sort it, you can see it went back to original list. So do you guys think reverse and sort are opposite? So here reverse is just flipping the order of indices. So it goes with the last one first, the second one, and third one. What sort mean is that you take a look at the values, not the index, and then sort it in the ascending order. So let's say you have 1, 2, 5, and 3. If you reverse it, you see it's 3, 3, 5, 2, 1. But if you sort it, that's gonna be 1, 2, 3, and 5. So they are not in a opposite, comment. Okay. And then you can use insert, for example, a dot insert 0 and 4. If you print it out, you can see it's 4, 1, 2, 5, 3. What it means is that you want to insert value at the 0th index value of 4. Okay, so you put at the 0th order 4 like this. Okay, and then if it's 1, you put it somewhere here in between. Okay, so it's gonna be 1, 4, 2, 5. Okay, and then if you do the same thing with the list of list like this, and then you can remove numbers by saying a dot remove, and then J, and then you can see 3 has been removed. And then let's say if you use, for example, 7 and 3 like this, you can see 3 has been also removed. So what it means is that it's not removing the third index, which is 0, 1, 2, and 3, which is 7, but it's removing the number value. So you removed 3 over here. What if you have multiple 3s? If you run it, you can see only the first one has been removed. How can we know this is the first one? We can try something like this and then see your first 3 has been removed, and then it goes by 4 and 3. Okay. And then you can also pop the value, for example, pop the value at the end. So when you do pop, you get rid of the last one. Okay. But if you put a number in it, for example, like this, you can pop the fourth one, 0, 1, 2, 3, and 4, which is this. So you see the difference between remove and pop. If you if you remove with the specific value inside, you want to get rid of this 3, that's appear for the first time. But then if you do pop, you find the index, and then you get rid of it. Okay. And then if you want to count the numbers that you have, for example, 3, there are two grids. So a dot count and 3, you can see it's 2. But then if you do 7, it's going to be just 1, right? And then if you have 10, you don't see any tens, so it's just 0. And then there's another command you can use, which is extend. And then let's say we have 1, 2, and 3, and then if we want to extend that to 4, and then you can see, oh, sorry, uh, like this, and then you can see it's extended to having 4 over here. And then that looks pretty similar as append. The main difference is that when you append a list, for example, a dot append 4 and 5, you'll see, okay, uh, you'll see that list inside of the list has been added over here. But then if you extend 4 and 5, you see it's appended without, not as it is, but getting rid of the list and then put only the components. Okay. So last thing we want to learn is dictionary. So the dictionary is composed of key and value. So always key and value. So for example, it's key 1 and value 1, key 2 and value 2, something like this. And then you want to declare that as a dictionary. Okay. So let's say if you have name, and then Kim, and then phone number, 111, 222, and 233, and then birthday, 1212, and that's gonna be the dictionary that you can make. So to make a dictionary, you can do have a like a middle bracket, and then you say name and Kim, name and Kim, phone number, 11, 222, and 333. Birthday, 1212. So that's your dictionary. So name, phone, and birth are keys of the dictionary. And then Kim, 111222, and 333, 1212 are values of dictionary. And then they are pair. Okay. If you want to declare an empty dictionary, you can do is equal to like this for the empty dictionary. Or another way you can do is like this for the empty dictionary. And then if you want to add key and value pairs inside, for example, you can DHT1 and then name, Kim, and then you can see, sorry, name should be Kim. And then you can see that name becoming key. So name is a key and Kim is value. Okay. And then if you can also delete the pair, for example, del dict1 and then name like this. You can see if there was name and Kim for the key and value, but then you got rid of name, so name and key pair has been gone. Okay. Um, if you wanna specifically add get the key and value pair, what you can do is that, for example, number 1, 2, 2, and 3, 3, 3, and then if you wanna just get the value given the key, you can just say with the bracket and the key inside to get the value out. Okay. And then, of course, you can also override the value by having the name and then say Lee, and you override Kim to Lee, Kim to Lee, and then if you see print this out, you can see it's Lee. Okay. And if you wanna, let's say, um, and then if you wanna get all the keys you have, what you can do is dict1.key to get all the keys. And then if you print it as, you can see all the keys, which are name, number, and birth. Okay. And then you can also use the same approach to loop into the keys. So for example, for as in dict1.keys, then if you print it out, you can see one by one, keys one by one, number, name, number, and birth. Okay. And then you can, this is if you print the S out, uh-huh, this is dictionary keys. And then you can also get all the values by values command to get all the values. So it's Kim 112233 and 1213. They are values. And then you can do the same thing like the key for the values. To print out to use it as for the for loop to iteratively get the values that you have. And if you wanna get existing item that you have, what you can do is to say items, and then you can see their keys and values in a tuple and list form. The difference between just print dict1 versus dict1 that item is that for the first one is in dictionary format, and then the second one is in list and tuple format. Okay, and then you can do the same. You can also use for loop for this. For example, for uh, for item in dict1 that items, this, and then print items to print out you know key and value pair in tuple. Okay, and then you can also clear dictionaries by clear this, and then you can also get the values by, for example, dict1 dot get, then for example number, then you can see its number. The main difference between just one that number, which looks the same, is that when you have, for example, ID which is not within the key, then you can just get the none as a return. But then if you just use this, then you can get an error. So that's the main difference. So by just using get, you don't get any errors, but just return none if there's no key within the dictionary. Okay, and then if you want to find within if a key is in the dictionary, you can just simply dict1, for example, name in dict1, then you get true as a boolean. But if you have name with the lowercase in dictionary1, you can see it's false. Okay. And then so we have finished covering all the variables. So and then other than that, you know loops for while, control statements, if, else, and then we can briefly cover function. So for the function, you can declare a function with def, and then the function name like this, and then with the parenthesis, and then you can write down anything you want. And then if you want to call it, so without calling it, you don't get anything, right? If you want to call it, you can just simply call it from outside, like this, to call it, okay? And then you can have input and output. For example, A is equal to 1, B is equal to 2. And then if you will put A and B, you can simply do like this. And then you also have to match that within the function input over here. And then if you want to say A plus B, and then you can see 3, right? And then you can also have output. For example, return A plus B. You can just have an output, and then say C is equal to function 1 of B, A and B. Then you can see C being A plus B, and then that's going to be 3, right? And then you can have as many input as possible, like this. Like this. And then you can also have multiple outputs. For example, addition, A plus B plus C, multiplication, A times B times C. Then you want to return addition and then multiplication. And then you can, if you print this, you are printing addition and multiplication at the same time. So you 6 and 6. But then if you want to break them down, then you have to do D and E. Then if you print out D and print E, you can see 6 and 6 separately. Okay, so that's function. Class, the class is different from function in that the function gets the reusable logic, whereas class you also capture data and logic at the same time. Okay, and then you can also say for some attributes while in class, while you cannot get any attributes unless you have global variables. And then we can start with the CLA ESS for the class. And then you can start with the class name, like this. And then you can do whatever you want from here. So say you wanna have a function within a class like this, and then print ABC. But then there are a number of different ways of using class, but including instance level method, class level method, static methods, and so on. But this is too in-depth in this class. So you should, if you are interested, you just wanna find it on Google about instance class setting methods. But what we're gonna do today is just a simple instance-based methods, which can start with init, and then with the init, you can do anything you want. For now, we'll just pass. And then for the instance based method, you always want to put self in the as an input because you're gonna use that throughout the class. And then if you want to call the class, you can say run, for example, run C1 is equal to class name. And then once you're running it, it automatically runs the init function. And then that's it. And then if you want to call function one, what you should do is that run underscore C1 and function one to call the function one. Okay. So without this, you don't print anything because when you are in line 8, you go to class and then call it, and then you automatically call init, and then it's passed, so you don't print anything. And then if you start calling the function one, then you are printing something. So let's say if you print small abc here and then big abc over there, you should see small abc, abc, and big abc like this when you run it, right? Okay, and then you can of course call function one within the other function inside of the class. For example, even under init, you can call other functions. So if you want to call function one under init, which runs when you call, automatically runs when you call class. So you can do function one plus function one to run function one. So when you run it, you can see running ABC, even though you just are calling class only. Okay. So with that, you can do whatever you want. For example, let's say function two in the class, and then you call def. Then for with the line 11, you just print ABC, but you can do function two to call def as well, like this. Okay. And then with that, you can do many things you want, as many as you want. So for example, let's say we wanna have an init number, and then you can probably do get the result is equal to init number. Oh, by the way, if you wanna share variable within a class, you can start have a variable starting with self. Okay, if you have self here, you can call it over here as well, over here as well. And then if you declare result here, that's different from this. Okay, so for example, let's say you have result and init number, and then somehow you want to use set the result over here, and then you'll print ABC and self result. So class name, and then init number be 3, and then that we declare CL, maybe 1, and then CL1 dot function 1. Then you'll see with class calling the class name, you are calling init, and then you say self result, which is init number, which is 3, and then you call function 1, and then you call print ABC, and then your result, which is 3. So when you run it, you see ABC and 3. And then if you declare result to be 10 here, that's different from this self.result. Okay? See, they are all different variables. And then with that, you can do as many as you want. For example, you make it as a calculator. And then you can, for example, have an init and then first number, second number, and then you say that result as for now 0, and then you first set the data, and then let's say you set the data first, second, and then you set first as self first, second as self second, like this. And then once you call it, you have to put first and second, and you are not printing anything, so you just get the result. And then what we're gonna do is to have an addition, which can be self first and self second, and then you return it. Okay, and then if you do cl1.add, you can get the summation like this, which is 3 plus 4, which is 7. And then you can do the same thing for subtraction. Minus, and then if you do subtraction, it goes like this. Okay. When you learn list, tuple, and anything like that, you remember dot something, grammar. That's pretty much like looks like class, and then if you can customize a class to have similar ways that you saw from tuple, list, and dictionaries. Okay. And then what I'm gonna explain from now on is a bit difficult, but I'm gonna just proceed. So you have a calculator function, and then let's say you wanna have power, which is, for example, 3 to the 4th. That's 4. That's 3 times 3 times 3 times 3. And then for some cases, we just wanna use as is, not adding anything. But then for some other cases, you wanna just have power term to have more feature. And let's say you have class more calculation, calculus, and then you call calculator, and then power, and then result be self first. And this is how you do power. Okay. What I'm doing is we have more calculation, and then I'm calling calculator, and then that's called inheritance. Okay. So let's say you have, for example, you have calculator, and then cl1.add print. You can see it's 7. If you do cl1.power, you get an error, right? Because you don't have attribute power, meaning your class doesn't have power function, right? But then if you have cl2 being more calculator, and then 3 and 4, and then if you print cl2.power, you can see it's running the power 3 to the fourth, which is 81. But another interesting thing is that you can also do CL2.add, which CL2.add, which is addition. So it means that when you call more calculation, you're running not only you have not only power function, you also have those other functions, and then you can even get the init function because you have 3 and 4. You're running first and second, and you have set data and then save the result. So this is we call it inheritance. So more calculation kind of get the all the features that calculator has. So you can think of it as your parents having, all the money or, uh, house. Because you are a son or a daughter, you can just have parents, assets. So that's related to that's what we call inheritance. Okay, so more calculator is a daughter or son of calculator by just putting the calculator class within the parentheses, and then you're using those features. But when you think about your parents, you don't give, you're close to your parents, right? So when you do more calculation, I mean, when you use calculator, you don't have this power feature. Okay, that's the difference. Okay, that is pretty much it. You know what class overriding? If you are overriding a class over here, for example, uh, let's say if you have difference subtraction for more power, say like this, which is totally made up, you can do something like this as well. And then if you do subtraction, it ideally, when you only use calculator, it's 3 minus 4, which is -1. But now this is 3 to the -4. Okay. But then if you use this, which is the parent calculator, and then do subtraction, you can see -1. So you see difference, right? Okay. I'm gonna give you one homework to do just to make sure if you get all these Python examples and features. And then yeah, see you next week.